Okay, graph question. Lots of key points to pay attention to here. Obviously, you've got a keyword parallel there. You need to know what that's all about. We've got a line which goes parallel to minus 2x plus 1 and passes through the points 5, 2. Um, so we've got a pair of coordinates here. That's obviously an x value. Oops, I've done that off camera, sorry. Let me start again with that. Excuse me. Right, well, I've just deleted parallel as well. There we go. So parallel, oh hell. This is not going well. Right, 5 is an x value and 2 is a y value. This is a pair of x and y that fit a relationship similar to y equals minus 2x plus 1, but parallel. Now, we can find out what the line is that is parallel to this one and passes through a specific point. We need to know what lines that are parallel with each other have in common. If lines are parallel, obviously there's minus 2x plus 1. Oh, that's not a good minus 2x plus 1. Let's try again. Right. If you have minus 2x plus 1 like that, it's a line that goes down 2 every time you go across 1 and goes through 1 on the x-axis. Oh, that's a beautiful line. There we go. So that's what y equals minus 2x plus 1 look like. And if you want parallel lines to that, you're going to have to put up with some more bad drawing, I'm afraid. Let's do a blue line. Oh, I really ought to put the line tool up. Never mind. I'm just getting used to this. So there's some parallel lines, very parallel, obviously. Also having a gradient of minus 2. So what I'm trying to say here in a very long roundabout sort of way is that we're looking for the equation of a line which is also y equals minus 2x plus something. We'll call it c. That's c corresponding to the value where it goes through the y-axis. So y equals minus 2x plus c. Obviously y and x are both variables. C is something that we need to work out for this particular line. So we then look at our pair of coordinates. We've got x here and y here. If we substitute them into this equation, we'll be able to work out what that plus c, because here's our point 5, 2, where is it? 5 along and 2 up. Let's say it's there, if that's 1 on the y-axis. There's the point 5, 2. There's the line that's parallel to our original. I know it's not very parallel, but hey. And so if we plug in our coordinates into this relationship, we can work out what c is. It's going to be this intercept up here. So if y is 2 and x is 5, we get 2 equals minus 2 times 5 plus c. So 2 equals minus 10 plus c. And from that you can work out that c is 12. 12 on the y-axis. Lovely. Okay, now we know that the equation of the line is y equals minus 2x plus c. Sorry, plus 12. We can go about finding out whereabouts this coincides with the axes. Well, to remember what the equations of the axes are, this is something that a lot of people wouldn't necessarily consider. The equations of the axes. On the x-axis, it's true that all the y values are 0, so this can be, the x-axis can be thought of as the y equals 0 line. And similarly, on the y-axis, all the x values are 0. So the y-axis is the x equals 0 line. Now what that means is, if you're trying to work out where your line goes through x equals 0 and through y equals 0, excuse me, you just substitute in y equals 0 and x equals 0 into your formula here. So if we substitute y equals 0, this will give us the x-axis intercept. Because we'll work out the value of y that goes with, sorry, the value of x that goes y being equal to 0. So we say 0 equals minus 2x plus 12. And from that, I think you can see that 2x is a 12. So x is 6, which means that the coordinate is x is 6, y is 0. And the x-intercept is 6, 0. We could do the same process here, substituting in x equals 0 to get the y-axis intercept. But we've kind of already done that because you know from your y equals mx plus c format that the c, which we worked out earlier, is the y-axis intercept. So if we stuck in x equals 0 here, obviously we just get y equals 12. Either way, we know that the y-axis intercept is at 0, 12. And that is the question solved.